Hello, this is a math affair, and today we're going to key in to one of our circle theorems. The title of this theorem is the opposite angles of a cyclic quadrilateral add up to 180. The opposite angles of a cyclic quadrilateral are supplementary, which means the same thing as add up to 180. Now, for this particular theorem to be true, we must have a quadrilateral, meaning a four-sided shape, completely circumscribed inside a circle. In other words, it's completely surrounded by a circle, so much so that the vertices, the corners of the quadrilateral, necessarily touch the circumference of the circle. That's what we call a cyclic quadrilateral. It's just a quadrilateral inside a circle. If one of the vertices of this quadrilateral does not touch the circumference, this theorem does not hold. So keep in mind, strictly our 4 points must be on the circumference. If our 4 points are on the circumference, then the theorem says the opposite angles add up to 180. What do we mean by opposite angles? We are referring to the diagonally opposite angles. In other words, I'm talking about if this angle right here is x, and that angle right there is y, these are the two diagonally opposite angles. So I could say in my diagram, x plus y is equal to 180 degrees. That's exactly what we mean by this theorem. The opposite angles add up to 180. Very simple, very straightforward. This would be true also for the other set of opposite angles. So if I decide to name this one as W, and let's call this one Z, then I would say here W plus Z is also equal to 180 degrees. So it's the diagonally opposite angles that add up to 180. Okay, so let's take a look at how we can apply this concept in questions. Okay, I have a question right here, and our question wants us to find x, find angle x, or find x, the size of x. We are given a cyclic quadrilateral to start with, and the 4 vertices are on the circumference. You always want to make sure you check for sure that our 4 corners or vertices necessarily touch the circumference. And if they do, then it also follows that the opposite angles add up to 180. So in our question here, we know that if I take my angle x right here and I add it to the angle 5x, the sum would be 180 degrees. So we are going to execute and take our x plus 5x and say all of this is equal to 180 degrees. This becomes a simple algebraic problem. I'm solving an equation for x. So x plus 5x would give me a 6x, which is equal to 180. Solving for x, I use reverse operations. The 6 is multiplying on this side. If I move it to the other side of my equal sign, I will have 180 divided by 6, which in this case is going to give me 30 degrees. And that's our solution. X is 30 degrees. The question did not really ask us to find the size of each angle in the diagram. It simply asked us to find x, or what is the value of x. And we solved and found x as 30. So that is our solution. So this is our theorem on cyclic quadrilaterals. Some say cyclic, just a difference in pronunciation there. Cyclic quadrilateral, the opposite angles add up to 180 degrees. Watch out for more on circle theorems.